Give it up for Patrik.
Okay, earlier someone showed a slide from some really old Erlang user conference, and there was one item that was embedded NT, and it was actually my speech. So then I got to talk about Windows, and now I'm going to talk about Unicode. So I get to hold all the popular speeches, you know, understand? Yeah. So this is not like a hardcore how it works speech. It's more like a bedtime story. And therefore, I've called it the tale of the programmer, the 8-bit character cave, and so on. So just relax and think about a fairy tale where you have this little programmer sitting in the 8-bit cave, guarded by the mighty dragon of backward compatibility. And he wants to move out into the fields of Unicode where everyone can send like cool messages in Japanese characters and things like that to each other. But this dragon, who isn't really a mean dragon, it's just a mighty dragon, and it's guarded by the king, King Ericsson, who uses the dragon to fire the furnaces of like, well, telecommunication and things like that. So, and also King Ericsson pays your wages, so you got to do, you can't kill the dragon. Okay? If you kill the dragon, he will be angry. Not the dragon, he's dead, but King Ericsson. So you sit there in your 8-bit cave and things are nice, but you want out. So what do? You try to get your remote control to work, yeah, which it doesn't, so no problem. So what we did, it wasn't like one programmer, but for the sake of the story, it's one programmer. So what we did was start to read up on what Unicode really is. So when I got this, when I think Björn came up to me and said, like, Patrik, can you do the Unicode support? And he's always trying to flatter me into doing things like that. And I was flattered, so okay, I can do that. I know what Unicode is, and I'll fix it. In Unicode, it's like that you get 2 characters for each Swedish character when you write on your Mac and you're really irritated. That's what Unicode is. So, but then I found this web page. Well, there's a Unicode consortium. This was a long time ago. Not as long as I would like for the sake of looking cool, but anyway. So what I found out was that Unicode defines these code points, and there's a lot of code points. There are actually more code points than fit in a 16-bit character, contrary to common beliefs. And code points define characters for all known, dead, and living languages, character sets, symbols, whatever. And not really everything. Contrary to common belief, Klingon is not included in the Unicode standard, for example. It's in the personal usage or private usage area of Unicode and defined by someone else. But like real languages all have code points. So they are compatible. The code points of the character set are compatible with US ASCII, the old character set used when I was young, and ISO Latin 1, which is the code point used in Western Europe. So the first part of the Unicode standard is the Latin 1 characters, and then beyond 256 code point, there are the other funky languages. So I wonder why my remote isn't working. Probably Unicode. So, but there's more. So if you have all those code points, you need to store them on the file or something. So you have the encodings. And encodings are what makes Unicode code points be bytes. So you have these code points like 127, and the encoding tells you this is a byte in UTF-8. If you have like 2024, it will be 2 bytes in UTF-8. In UTF-16, you have 2 bytes for almost everything, but 4 bytes for some of the really, really weird character sets. For me, weird. For someone else, the natural way. And for example, 4,711 will be 3 bytes in UTF-8. And the thing about UTF-8 is that it's really common. So even though UTF-8 might seem strange because it has variable number of bytes per character and so on, it's really a common encoding. So there's 3 encodings that are defined in the standard, and there's some UCS encodings that are very similar to these 3 encodings. So there's UTF-8 used by Mac, for example, UTF-16 used by Windows, for example, but not really, because Windows has forgotten about the code points that's beyond what can be stored in 1 16-bit characters. And UTF-32, which is the nice encoding because each character takes exactly 1 unit, exactly 4 bytes. And as the UTF-16 and UTF-32 have more than 1 byte, they have not decided on a byte order, of course, so there's little and big endian of it. But what we forget is usually that we had an encoding before. When we have to think of it like we had an encoding before. We had isolating 1 characters. They were numbered from 0 to 255. And when we wrote it to a file, we decided on a way to write it on the file. Or we didn't decide because it was obvious. I mean, they all fit in 1 byte. So we encoded each character, each code point in our isolating 1 character set into 1 byte in files or binaries or whatever. So we could call that byte-wise encoding. So each character, 1 byte. That's what we used. And sitting in our 8-bit cave, that was all we needed. So, and it had these enormous advantages. It was compact. Each character took exactly the same amount of space. So if you wanted to count how many characters is in this text file, you just looked at how big is this text file. And so on. And life was good, so good that we didn't even think about how good it was. But it wasn't really good, because if we wanted to write Japanese characters, we were like fried. So we had different character sets for different languages, and 1 text file with byte-wise encoded Latin 1. If you read it in Greek, it looked like nothing readable. So you had to know what character set you used and so on. So it wasn't all that good. So, but encoding and character sets are often confused. And I confused them, but then the mighty wizard of Unicode came down to the little programmer and said, write this on the blackboard 1,000 times. And I did that. And I didn't get it anyway, but now I get it. So do not confuse character sets with encodings. You can encode whatever in UTF-8. You can encode US ASCII in UTF-8. It's somewhat compatible. You can encode Latin 1 in UTF-8, and you can even try to encode Unicode in byte-wise encoding. You will succeed until you have a Unicode characters that's beyond 255. Let's look at UTF-8 because we like it in the Erlang world. So this little programmer in his cave decided that UTF-8 is cool and looked at it and thought it's also backwards compatible. If you read about UTF-8, it's backwards compatible, and it is with US ASCII. So all Americans think it's backwards compatible. But it's not backwards compatible with byte-wise encoding of isolating 1. Because every character beyond 127 will be encoded in 2 bytes. So even though the character set isolating 1 is a subset of the Unicode character set. If you encode it in UTF-8, only the 7-bit ASCII is backwards compatible. And that's a problem, and that's something that people get into trouble with. So UTF-8 encoded characters is not backwards compatible with byte-wise encoding isolating 1 characters. Always remember that, and write it on your blackboard. Okay. So, well, we decided on a representation. Part of the decision was already made because we had some parts of the UTP that actually could represent Unicode characters, and that was the Corby implementation. If you have, every day you use Corby. Okay, but at that time it was still popular. Anyway, Unicode was represented as lists of integers, each representing 1 code point. And that's like a good thing, because lists of integers is strings in Erlang, and 1 string takes about a gazillion of bytes every time, because you have like up to 64-bit numbers for each character. So moving to Unicode didn't change the space usage of a string. It was still a gazillion bytes, but it wasn't worse. So we could utilize the fact that we had place for Unicode characters in the strings, and just went on using Unicode strings as byte-wise, as code point-wise lists of integers. But in a binary is essentially a byte-oriented thing. It's like a file or something. So you can't just say, OK, put the Unicode code points in the binary. How? That's when you have to have an encoding, and we decided UTF-8 is the encoding in binaries. It's not the only encoding, but it's the encoding with a capital E. So UTF-8 is the encoding used when when we don't communicate with the outside world. So if a module in OTP can handle Unicode binaries, it will handle UTF-8. It will possibly handle something else too, but it will handle UTF-8. So, for example, the Unicode module handles a lot of encodings and the bit syntax. But anyway. So, and if you program some Erlang, you've also seen the IO lists, which is a weird, possibly deep list of integers and binaries in the tail and things like that, which you can send to port or something. It's a couple of bytes encoded either in lists or in binaries, and then smashed together, and they will be a stream of bytes sent to the port or on the TCP socket or something. We have a similar thing now, which is called the Unicode car list, which is Unicode code points in lists, possibly deep, and so on, and then UTF-8 binaries mixed with them. So that's a Unicode car list. And it's not an IO list, because the Unicode code points are not bytes. So you have to if you want to send it on a byte-oriented device, like a TCP socket, you have to convert it to bytes in some way. As long as it's only binaries, it's bytes. But if you have characters, they have to be encoded, because if you want to have Unicode characters put on a device, you have to have an encoding. So, the first thing we wrote was the Unicode conversion module, which is called Unicode. Tada! What it has is basically 2 functions: characters to list and characters to binary. And characters is usually this car data thing. So it can be a list of characters. You write it directly in the shell. You write your funky Japanese characters in the shell and convert it to binary in UTF-8 by using characters to binary, or you have your binary and convert it to a list by characters to list. So, but characters to-list can also have an in-encoding, which tells you what encoding you have in the binaries. So if you say it's Latin 1, it will be byte-wise encoding, and so on. And here you see this. I hadn't read the blackboard I had written full of "do not confuse encodings and character sets." And that's actually because the common way to describe byte-wise encoding is Latin 1 encoding, which is wrong because it's byte-wise Latin 1 encoding, possibly, but as an encoding, it's byte-wise. But it's called Latin 1. In Emacs, if you say I have byte-wise encoding and Latin 1 characters, I write encoding Latin 1, and so on. Also, to emphasize that UTF-8 is the default encoding for Unicode characters in binaries, we call Unicode is an alias for UTF-8. That's bad decisions that are already there. And you know, the dragon of backwards compatibility say you can't put that back in the box. Okay, so we have the other way around, characters to binary. You can encode anything in 8-bit UTF-8 binaries. You can encode anything as whatever you want. So that's basically all you need to be able to handle Unicode characters. You can encode them as binaries. You can put them out on whatever device can read a special encoding, and so on. So just to make you happy, we added it to the bit syntax, which was done by Björn, I think. That was good because when I was wrong with how to do encodings, I could always look at what he had done, and in theory, vice versa, but in reality, only in that way. So you can match an encoded character as UTF-8 from anywhere in a binary. You can construct in all the encodings, UTF-8, UTF-16, UTF-32. You can have a literal directly in your program and write some encoding then after if you want it encoded. So the syntactic sugar that's always been there in binaries for byte-wise encoding is also there for UTF-8 and so on. So this is Odysseus in Greek characters, which you can write directly into your source file nowadays. But you always have to tell how to encode it. So if you hadn't written /UTF-8 there, Erlang would have expected that you meant byte-wise encoding. 1 byte per character, which will be really hard as all those characters are larger than 255. And the result would be surprising, because what does the bit syntax do if something is too large? Anyone knows? Truncates. That's right. Kenneth knows. It truncates. So we would truncate this to something really surprising. So don't forget to put the encoding there. So any string literal can contain Unicode characters literally written. So as in this example, if your input device can support writing Unicode characters, which is often the case with the shell or something. You have a terminal that can input Unicode characters. When we wrote this wasn't common. So this has changed over the years. So having a terminal that could input Unicode characters was mostly a Windows thing at that time. You were happy if you could input 8-bit characters, and your Kermit connection would eat the 8th bit all the time. But anyway. So then you want to do I/O, of course, of this. And the I/O system of Erlang is one crazy thing, which has these I/O servers, which takes messages written, sent from the I/O with the I/O module and things like that, or the file module. And doing this in a backward compatible way wasn't really easy because everything was like byte oriented. So you always expected all characters to be bytes. But we did a fair job by using the I/O module, which is was mostly used for terminal I/O, and made that Unicode aware. So the I/O module handles characters, which is possibly Unicode characters, while the file module handles bytes, except for file open, which can handle Unicode, but that's another thing. But so if you work with the I/O module, actually everything that's in a binary is more or less supposed to be in UTF-8. Not in I/O format, but you see. And that's not a big problem, because the I/O module is mostly centered around characters in lists. So if you have a binary, OK, you had a small incompatibility, but that was a long time ago, and you've all forgotten about it. So the I/O server that takes the thing that the I/O module sends to it in Unicode also has an encoding to tell it what to do with it when it puts it on a file, for example. So you can do get-ops and possibly set-ops to see what encoding it has. So if it has anything else than Latin 1, you can send any character to it. It will know what to do with it. So the I/O server is, so to say, the machine that we saw in the earlier picture, the thing, the cyberpunk machinery that translated from Unicode characters to one encoding. So the encoding translation you can see by doing get-ops on any I/O server, and that's a file, for example. And you can also open a file. So file open can open a file, and you can tell that the characters are going to be in UTF-8 on the file. So you can do the translation directly in the I/O servers, and that's done, for example, in the terminal, the standard I/O. So if you do I/O get-ops on standard I/O, you will probably get encoding Unicode, which is UTF-8. OK. But regardless of the encoding in the I/O server, the I/O module takes Unicode parameters and handles Unicode. So the only thing that happens if you have encoding Latin 1 on your I/O server is that it fails when you send characters beyond 255 to it. So it doesn't like change the type specification depending on whatever you send it to it. So I/O put cars takes a Unicode car list as parameters. So if you send a Unicode car list, it will send it directly as it is to the I/O server, and the I/O server is responsible for translating this to an encoding to put on the file. So actually, for example, for the terminal, the I/O server can take any character regardless of if it's actually able to have to encode it on the file. So it will output a lot of \x, curly brackets, blah, 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 instead if it can't encode the characters. But a file, for example, will give you an arrow that says no translation. A Unicode character beyond 255 has no translation to byte-wise encoded file. So the file module, on the other hand, handles bytes. So don't send any Unicode car list to it. It handles I/O lists, which is like kind of nearly a subset, but not really. So, and do not open a file for output of UTF-8 or input of UTF-8 characters, and then use the file module to read and write from it. It will be confusion. So the rule number 2 is do not use the file module to read and write files that are not in Latin 1 encoding, where Latin 1 means byte-wise encoding, because I have broken the first rule of Unicode. OK, everyone's with me? Yeah? Great. OK, so now you can open files, you can send Unicode characters to it, you can handle Unicode characters, you can write them in your program, and now you want to use I/O format. And here's where the dragon of backward compatibility really was really angry at me in the beginning, and then he forced me by breathing fire in my face to add the T modifier. The T modifier, it says, okay, this is Unicode. T as in, this is Unicode. U was taken, okay? So if you do tilde s in IO format, means this is a string. It takes a binary, a string, or possibly a deep list of characters or something, and puts it out as a string. Everyone knows that. In tilde s means also that the binaries are byte-wise encoded, because that's how it's always been. So we can't change that. So tilde ts means that the Unicode, we have Unicode characters in the list. That means it's a bigger range of characters, and the binaries are in UTF-8. And again, to help the sloppy programmer, if UTF-8 conversion fails, it will actually accept the byte-wise encoded binary. Don't rely on that, but it does. So, but the upside of this, if there is an upside, is that if you do not use the T modifier, you will get an IO list back from, for example, IO-lib format. And that was one of the important things when it came to backward compatibility, because a lot of systems use IO-lib format to format things that they directly send to ports, and they need to be bytes. So if you don't use the T modifier, you will not get Unicode characters, and you will get a list with bytes from IO-lib format, which is a good thing then, supposed to be a good thing. Tilde p, it's this heuristic function that tries to find strings when it prints them, and it will do as it always done with tilde p. With tilde t, p, it will find strings in UTF-8 encoded binaries too. And it will find lists with Unicode characters in it. So what will happen is, as tilde p is what you use in the shell. So if any Unicode character will be interpreted as part of a string, what will happen when you write list sec something? You will get really funky characters in your terminal. And they're probably Ferengi. Because every list of integers will more or less be interpreted as a character list. So it will output it as a string. Most probably a string with characters that your terminal cannot handle. So you will get these funny faces and things like that on your terminal. So heuristics for determining if a list of integers is a string, it works well if you have a limited number of numbers that can be characters. It's still limited, but it's like 7,000 to 8,000 characters out there in the Unicode character set. So every list of integers, more or less, will be interpreted as a string. So we have to have a notion of the language in the language you like, the language that will contain, that your strings will be written in. And as it is now, you can only limit it to the Latin 1 character set. So if you start Erlang with plus PC Latin 1, it means printable characters are Latin 1 characters. You can also use Erl plus PC Unicode. That means printable characters over every character, and you will get surprised. But I often use plus PC Unicode because I work with Unicode encoding, but most people like Latin 1 better, and that's the default. So let's look at IO format then. Tilde p of åkerspöke, which is a common Swedish word. If you write åkerspöke as byte-wise encoded binary and as UTF-8, and then write Odysseus in UTF-8. If you have plus PC Latin 1, only, if you write tilde p, only åkerspöke in byte-wise encoding will be all right. The rest will be interpreted as a binary and print out as a binary. If you do with tilde tp, it will find the UTF-8 characters of åkerspöke, but it will ignore Odysseus because it's not Latin 1 characters. So instead, if you do this. You started with plus PC Unicode and then do the same thing. You see with tilde TP, all the Åkersberg's and Odysseus will be printed out as UTF-8 binaries. But if you do list sec 2010, 2720, you will get these really cool things on your terminal, which is probably Åkersberg in some other language. I have no idea what kind of character that is. Looks Arabic, but I have no idea. So if you have plus PC Unicode, you will see a lot of lists of integers really badly interpreted. So we'll see what to do about that in next step, or if I ever come to future work slide, I will talk about that again. So, and the shell, it will handle Unicode characters if you have a modern terminal, which you will have if you use Linux, if you use Mac, if you use Windows. If you use VxWorks, I don't know. Okay, so it determines if you have a UTF-8 terminal from the language environment. So the best way to confuse everyone is to set lang to something using isolating 1 and then turn on UTF-8 handling in your terminal. Then everything will look really funny. And it's fun for a while, but probably you want to keep these in sync. So you say, my language is Swedish with UTF-8 characters, and then set the terminal to be a UTF-8 terminal. Everything will be smooth. So there's actually a user's guide. A few people know that in standard library. If you look in that, there's two things there. There's one using Unicode in Erlang, and there's one how the I/O system works thingy. Read them. They're really interesting, and it's a really good writer who has written them. Promise, true story. But they're actually kind of readable anyway. So you can also specifically set the terminal to output UTF-8 characters if for some reason it doesn't detect UTF-8. So you can do setups, and that you can do regardless of what kind of terminal. The detection by language or LCC type is done in the new shell, which is the ordinary shell when you start Erlang. But if you start with -old shell or -no shell, you will get another I/O server that's for pipes and things like that, if you're writing a filter in Erlang or something like it. That one has Latin 1 or byte-wise encoding default for backward compatibility reasons. So then you have to use I/O setups to set UTF-8 encoding. You can always use I/O getops to see what encoding it is. So, and when we've done all this, you can write things in Unicode, you can get them encoded in UTF-16 little endian and things like that, and it's easy. You just do I/O format and you work like you did before. You just set an option when you open the file, and then everything will be written in this encoding, and everything is nice. And then the first thing you'll try is to name a file Åkersberg, or Odysseus, possibly. And then you see that there's a whole new area of problems when it comes to file naming. To begin with, you read up on Unicode file naming in different operating systems, and they are really proud in Linux of the transparent file naming. We have transparent file naming. It's the way to do it. That means we don't care. That's the way to do it. You can name your files however you want, and you can use any encoding, and encoding is by convention. So you could say, no, encoding is the same as for the terminal. You can see it from the lang environment. Yeah, but like files will stay there even if you change terminal. So whoever created the file had one encoding. Whoever is reading, trying to open the file, might have another encoding. So transparent means we haven't thought about it really, but we're really proud about it. So that's how we do it. Not they, but well, they did it too. So the convention cannot simply be assumed by but sometimes it can be assumed, or it's probable that if your language environment says that you use UTF-8 characters, the file names will be in UTF-8 characters. But it's not so probable, so you can rely upon it. So on the other hand, there's other operating systems like the Mac OS X and Windows, which have done the right thing. Tada! They enforce it. So if you, however you name a file, it's always a valid Unicode file name. So on those operating systems, it's on by default, handling Unicode file names. For backward compatibility reasons, tada, when in doubt, we regard every file name as byte-wise encoded, because that always works. It looks like shit, but it works. So if you list a directory, you get really weird file names, but they're there. If you list a directory with byte-wise encoded Latinate 1 file names and have Unicode file naming, what would happen? Yeah, you can't translate the Åkersböke in Latin 1 encoding to UTF-8 because you don't really know what it is. You can maybe get 2 files with the same name if you use heuristics to determine the encoding and so on. So you can't do that. So when in doubt, we use byte-wise encoding for file names. If you want to be brave, you can turn on Unicode file naming, which you can be if you have a modern computer and it's your own computer and you have no other users there that ruin everything. So then you start Erlang with +fnu, which is file names in Unix. Those weren't taken. You can also have fnuw, which means file names in Unicode and warn me if I get into trouble. So then you get all these warnings if you have file names in your file system that are not properly encoded. You can also be semi-brave and look at the language environment and decide from that. So FNA, file names automatic. And you can also have file names automatic E, which means ignore all file names that cannot be translated. So, well, this also affects, for example, open port. If you do spawn executable to start a program, how should I interpret the file name of the executable? So if you have said file names in Unicode, named your program Odysseus in Greek, and want to start it, you can use spawn executable if you've started with +fnu. Otherwise, you will find out what's the 8-bit or UTF-8 encoding of the file name on the file system, and then don't do that. So also environment variables, if you have environment variables with Åkersböke in, if you have started with fnu, it will expect them to be in UTF-8 encoding, which is the way most operating systems do it nowadays. So fnu is probably a good idea on most modern Linuxes. Then the source files, which is the new thing in R16, together with some of the other things, is that they can be in UTF-8. They cannot be in UTF-16 or something. They have to be in UTF-8 or byte-wise Latin 1 encoding. And just as in Python, you specify this on one of the two uppermost lines in a comment or whatever you want that can be read by the compiler. And you have a line that matches this regular expression, coding, a number of spaces, colon or equal sign, a number of spaces, and then a bunch of characters, including dashes. And the bunch of characters, which is the sub-expression there, should match either Latin-1 or UTF-8. And that's the same convention that a lot of other programming languages use. So you can write, for example, coding colon UTF-8, or I've settled for encoding equals Latin 1, or with coding colon Latin 1, I mean byte-wise encoding, which you can write a lot of times on your Blackboard too. So and literals in the source code, as Because in the shell, you can write alpha, beta directly. That will be a list with 2 integers representing the code points for alpha and beta. You can write, like I did before, you can write a binary with an encoding. The encoding can be anything. But if you do the last thing, you write characters beyond 255 in the source file, you will get the horror of truncation. So byte-wise encoding of characters that don't fit in a byte will be truncated. It will not be an error. That's important. So if you had byte-wise encoding of the source file, this would have produced an UTF-8 binary, because if you input UTF-8 characters and byte-wise encoding, it would take character per character, create a binary with it, and it would by accident be UTF-8. This has been utilized. Don't do that. Don't ever do that. Always tell what encoding you should have, because otherwise the encoding of your source file has impact on the semantics of your program, which is not what you want. So don't ever do that. Björn Egel. So, what's not there? I have 1 minute to tell what's not there. It's so little that's not there, so it's no problem. We don't handle graphemes. I think I mentioned graphemes. A grapheme is what you perceive as a character. And that's not always only one code point. It could be, for example, the letter Ö in Swedish could be represented either as what's also the Latin 1 number for Ö. It can be represented as the code point for O, followed by the code point for 2 dots over the character that's before me. Really clever, isn't it? And it looks the same way when you print it. So there's no real grapheme support in our libraries. But we'll see how to handle that. And Erlang has no notion of language. So to upper and to lower cannot be implemented. And you say, what? I need those, don't you? But it's actually true. If you have no notion of language, you cannot properly implement to upper and to lower. So you can use open source projects will come to the rescue. For example, I18N, library mapping of Erlang. That's the thing to use, probably. It has added all the language specifics to Erlang. So you can format date strings for Taiwanese. You can do anything like it. And it has to upper and to lower. Also, the beautiful languages of Elixir have what's called language-independent upcase and downcase in the module string. You can use that if you don't really care about the language specifics of upcase and downcase. So, for example, if you use Elixir string downcase on Odysseus, you will get something that's kind of right. It's correct if you have no notion of language. Because if you map upcase characters to downcase and don't know if this is a word or something, this is what happens. So correct in some sense. If you use I18N, you will get this, which is correct in some other sense, because downcase sigma in the end of a word should look like a C which has thrown up. That's all I know about it. So I18N does the right thing. Elixir does whatever it can do, because it has no notional language. So it doesn't know that in Greek you're supposed to do downcase sigma as the last character in this way. I hope. Yeah, because this is nodding. You look at German, you have sharp S. You do upcase and lowercase, and you get 2 S's. this is like hopeless. You can't do anything about it. This is supposed to be two different words. Massen, or however it's pronounced, with sharp S, and massen with two S's is two different things. But you can't do anything about it. No one can. There's no solution to it. It has no uppercase version, and in uppercase, sharp S is two S's. And however are you going to find out that it was a sharp S? So that's hopeless. So even I18N library cannot do anything about it. The I18N library is a mapping to the C library, which is the C library of handling things like that. So it does whatever it can, as best as it can. So then if we look at I18N and take the Turkish, I think it's a city, and it's pronounced, I don't know. And it has a couple of I's without dots, small I without dot. If you capitalize that, you will get large I without dot. And if you downcase it, you will get, yeah, you know what you do with a big I, you downcase it to a small I with dots. So, and then you have not realized you're speaking Turkish. So if you tell it my language is Turkish, it will do the right thing. It will downcase capital I to small I without dots. But then you have to know all these things about languages. And we have no support for that in Erlang yet. So there's a summary. If you download my thing there, there's a large summary of all the options. But you should read, actually, for real, you should read this part of the Erlang, the standard lib users guide, which is actually have all the summaries and also explains a lot of things that I haven't got time to explain here. Or I haven't explained anything, I've just ranted about it. But anyway, so what we want to do is make Unicode file naming default, probably. Because when we started with Unicode file naming, which is interesting enough, I think Danne told me that I had to fix the Unicode file names, and I said, that one is easy, I'll make it next week. It took me like 3 months or something. It was really weird, and he laughed at me all the time. Anyway, we want more options to plus PC. Latin 1 and Unicode isn't enough. There's other options you want. You want to say, for example, I speak Greek and Swedish, or I speak German and Swedish, or something like that. So strings that are in German and Swedish, I want the heuristics of Erlang to output as strings. Other things like Japanese is not my thing. So we want to support installation Unicode path, and in this case, I've had the chance to get back at Danne because he is fixing that one. So installation in the Unicode path means that you can put Erlang in a directory that has characters in the name that are beyond 255, and that sounds like really easy because we can handle those, but that's not easy. There's a lot of programs around Erlang that has to find a directory, and they have to be converted to handle Unicode file names and things like that. Open port spawn executable handles Unicode, but open port spawn does not yet. That's conceptually easy to implement because it takes a string, not a binary, and the string is backwards compatible. So that may be in R17, maybe. Upcase and lowercase, we have to solve it. I mean, that's what everyone wants to do. When you have a string, you want to capitalize it. So either by adding language support to the language, that will be easy. I'll do it in a week. Or a simpler approach like an elixir. Okay, you get some characters wrong, but most characters right. Or fix that scheduler and implement I18N, or integrate I18N, because now it's implemented as NIFs, and if you send like a book to it, it will process a book in one schedule. And you won't get happy. Your real-time characteristics, the schedulers will blow up in your face, and Rickard will send evil emails to you, and whatever. So if we fix dirty scheduling, which means schedulers that can be put on hold for a long time, we can integrate I18N probably. Atoms in Unicode is not supported, so the language still has the Latin one character set, except in string literals. But we hope to bring a full Unicode range to the atoms, maybe to the variables. There's a big debate, or has been a debate, where Richard O'Keefe, the one they told you held a speech that no one understands, thinks we should have it in variables, and I think I agree, but others don't. So we have to have a string library that's better, obviously. And we may want, if you look at Elixir, have you looked at Elixir? Has anyone looked at Elixir? Yeah. It's really cool. Look at it. And they have all the string literals are UTF-8 binaries. And it's so much easier to write. We can't do that, the dragon, you know, of backwards compatibility. But maybe a simpler literal syntax for UTF-8 binaries. As it is now, less than, double quote, blah, 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 double quote, slash UTF-8, less, greater than, isn't all that fun to write. So we'll see. I've tried for all this speech to use the remote, even though I know it doesn't work. Isn't that interesting? I'm so stupid. Okay, questions? None. No. I would like to smash the schedule for this. Yeah. Okay.